Next, we'll take a look at our address class table. Looking at the first unintended or IP. Take a look here. 1 through 127 is a class set.
Hello. You can go to the top of the class. There's a link that says live link only. And the code's up on the board. Follow the directions under that link. It tells you what to do, how to connect to the session. You're going to connect to my computer up here so that the overhead tonight. Just make sure and click on the, there's a green button at the bottom after you enter in the code. Make sure you click on the green button for the web only connection, not the download connection. It should be a big green button is what you want to click on after you type in the code. Then you have to put in your code and the code up there and your name. Those just coming in at the top of our class, there's a live link only during the class link. You'll need to click on that, enter the code on the overhead or on the board, and put in your name and hit the green button at the bottom. There's a link inside of our class you'll need to click on to see my screen. And the code's on the board. Make sure you click on the bottom green button. You click on the other one, it'll try to download something. We want to run it in the web interface only.
Well, I think actually if you disconnect that, I got the.
They probably have it hard coded on the IP address. You need to set it to auto config.
It is on auto config. It's just like we've got blue cables here. Some kind of final. I literally just took the Pacific. Like Pacific trails or whatever. Completely copied all of it. And then just changed the words and things like I didn't even change the colors. I didn't change the sounds and things like that. It seems very familiar.
PCT110.
And then the webcam that I made, like, just it didn't work. How did you get to the site? Like, what is the extension? Like, what would that type of what would you type in for yours? Oh, it's not. Oh, I didn't know. There, I'm sure it will. You said that they paid for it.
We never put it live. It's locally on my computer.
So that you pay for it.
Maybe that's new. He didn't know it was. I wish it was because I could just go on the website and I'm actually.
You can get those.
You're talking about it?
I just went to like the W3 schools and just copied this original.
That's
I lost 30 points.
what probably the most trouble.
I put a marquee on there.
No, really.
Oh yeah.
He said the same thing on the outside.
Huh? Change version 4. Yeah, it's good. I can restart the switch.
Put the live link and then
It might take a while. Might take about 3 or 4 minutes sometimes come in.
I think it's CIS. So he was teaching
Yeah.
me, like,
Save that. Please save it.
second. I'll take it.
Yeah, that's like a prerequisite for all the so I have to look at didn't take that. I had to take that probably a whole semester just to take that class. So I had to go in fractionally office like administration office like every day. They just my class on schedule. So so much trouble trying to get this.
Same second. I just plugged it in.
I heard it.
It's like a block. It's like how do you use words and stuff. But doing the news class and I have to take this class.
I did it fine. So.
Still working. Still working. I'm almost finished. Still like that. Anybody else need help getting online? It should be good. Okay, good. All right, so the code's on the board. If you log into Eagle, you'll need to put that code in and we'll get that top link and use the bottom green button to see my monitor. What now? The bottom green button. Going to be a web browser.
When you
Yep.
say tab link, where is
Excuse me?
that? Or your live link?
Yep. And the code's on the board, and you'll need to click on the green button that says web browser only. Do not click on the one that does not say web browser. So we got Barry in, Tom's in, Jenner, Christian. All right, is everybody in? Should see my monitor in front of you. Okay, a couple things I want to go over first is, don't get out of that. Next week is your research night. We talked about this before break. It's a night to start your research paper. And so you don't have to come on campus for this, but you do need to start your outline if you've not already started it, and do have to submit some stuff to me when you're done. So you're going to work on your research paper and presentation next week outside of class. Use this class time if you want to come on campus like you normally do, or if you're already here, to get away in the lab somewhere downstairs or anywhere on campus to get some stuff done. I do have a podcast for you to watch. It's a Prezi that you'll watch next week on how to create an outline. I'll go through some steps that's helped me over the years that hopefully will help you on how to create an outline. So you'll watch that. Pull that out. Then you'll just tell me what you accomplished for your research paper presentation. Pretty simple, right? Get that? So no, do not come to class next week. You'll be working on your research paper outline for sure. And creating an outline is going to help you when it comes to gathering your data to make sure that you kind of stay focused on what you need to stay focused on. All right? Also, before we get into the notes tonight, there is a network call labs that you can click on when you get home, but I want to show it to you here in the classroom. Okay, what this is it's a script that you will use to call local businesses to figure out what they have for their network, or maybe figure out that they don't know what they have for their network. One of the two. All right. I suggest creating a list of 20 local businesses. It can be hospitals, clinics, insurance offices, businesses that you know here in town. It can be high schools. It can be colleges like our own. And come up with a list of 15 or 20 numbers is what you want to do first before you ever start anything. And you'll sit down with this script and go over it, and I'll help you with it. So what you'll do basically is you'll call and ask for the network administrator. Once a person answers a phone, they don't know what you're talking about. You might say IT administrator or the person that works on your computers, something like that. But always start with the network administrator first. Then you'll basically, when you get to that person, if they do pick up the phone, you'll say, hello, my name is Chuck Conkle, networking student from Rock Valley College. What's your name? Pause and wait for them to tell you what their name is. Maybe it's John Smith. John, I've been asked to call 5 top businesses and ask them to make it their network. Environment. This is supposed to help me understand how networks are used by top businesses in a real world setting. Could I ask you 7 questions about your network? Now, right off the bat, you're already immediately lifting that person up that they are a top business. And you want to hear what they have to say about networking. You're a student, want to hear. So you're immediately letting them know that you value their opinion before they even give you their opinion. And so if you've never done cold calling before, some of you might have done before, I don't know. That's what this is basically. The difference is students have been doing the same assignment for me for 20 years. So more than likely, you'll call somebody that's had the same call before. Because this is now my 40th time teaching this, that I've taught this every semester. And so more than likely, you'll call a business like Rock Valley, like the OSF, like Swedish American. You'll get a contact with probably even a past student that's over that area now, and we'll help you answer the questions. Now, if they're busy, which a lot of them will be, you can say, would you mind if I emailed you the questions? You can say that as well. And because many of them are busy, don't have time, say, give me your email and I'll shoot them to you immediately, and you can get back to me when you can. Thank you for your time. Period. Right? And go on to the next number. If they keep asking, if they have time and want to talk to you, which majority of them probably will not, but if they do, you can go on and ask the question. And basically what you're going to do is if it's a no or they don't know, just go on to the next number. Don't try to explain something. A lot of times people will get offended if you do that, especially being a student and they're an IT manager or they're a tech person or something. So it's just best to just, if they don't know or you can tell they don't know, you can just go on to the next one. Say, that's fine. We'll go on to the next question. Something like that. Make sense? You don't want to make them feel weird. So anyway, the first question is, does your network use Ethernet, token ring, or both? They might say, don't know. Great. Number 2 question, what's the transmission speed of your network? They might say gigabit. They might say, don't know. What type of backbone does your network rely upon? They could say fiber. They could say Cat5 fiber. They could say, don't know. What type of wiring does your network use? Is it the same type for the backbone of the workstations? They might say, yeah, we'll use Cat5 throughout, even to our servers, or we might say Cat5 on our computers and fiber on our servers. Do you use WAN technologies? What topologies do you use in each one of your locations and how are they arranged? Remember, WAN technologies is any technology that uses an internet connection for that network connection. If money was no object, what type of upgrades would you make to your network? You might get stuff like gigabit switches. You might get stuff like SANs units. You might get stuff like new servers, new computers, whatever, a whole list of things. Then the next one is if you had money, only had enough money for one of these upgrades, what would it be? Upon completion, what I'm going to have you do is compile one per company. The one thing I do not have on this that you can put on there yourself when you download it is you can type in a company name for me. I don't have it in here. And I compile these into an Excel spreadsheet when you're done. And you have a few weeks to work on this. It's not due Sunday, okay? And so I'll go back to the due date on this real quick. I believe it's due week 12. We're in week 9 now. Yeah, so I'm going to have it due week 12. So you got this week, next week, week after. Actually 3 weeks to work on it. Sitting down, you can probably get it done in an hour, if that long. Get the whole thing knocked out. If you get kickback of at least 2 to 3 people, that's a good thing out of 20. Okay, meaning you literally got a response via email or they talk to you on the phone. Out of 20 numbers, that's really good. If you only get 1 or 2, you're fine. That's great. Okay, I don't expect you to get all 20 because when you're cold calling, 1 to 3 out of 20 cold calls is pretty good. That's pretty good actually. And so, make sense? So you got a few weeks to play with that. And when you're done, you'll submit it in week 12 in a few weeks here. Tonight, we're going to be doing a take-home subnet, which I'm going to hand out to you after our discussion. But I will walk you through the subnet. The subnet basically is going to show you how to, first, I'll have to walk you through how to convert a binary to decimal and decimal to binary. So it'll take a whole maybe 15, 20 minutes to go through that to help you out. And then you can do the rest by hand and bring it back in 2 weeks. Just fill it out. We're going to cover chapter 9 tonight in discussion. Before we do, though, we do have a couple postings I want to talk about that was recently put out. And they still yet have filled these. This one right here. This entry-level desktop support is yet to be filled, and they're going to maybe hire even more than one. It's Advanced Machine and Engineering Company, Rockford Networking, and they're looking for a student part-time in the IT department for desktop support. If you're interested, email the resume to that person I have on that document there, and you can put me down as a reference if you want to. But they still yet have hired someone. So, questions on that? So again, myrvc.org is where you want to find that out. There we go. That's what I'm looking for. All right. So we're going to look tonight at networking systems. Here in a few weeks, you'll be installing clients on the popular networking operating systems, which will be Microsoft, Linux, and Mac OS server. And some of the characteristics about those is what we're going to talk about tonight. A network operating system is different than a Windows operating system that you're used to using at home and at work, which would be like Windows 7, Windows 10, Windows 8. The operating system for a server is designed to work on a server and to manage multiple computers. It's also designed to have multiple processors, up to 32 processors that it can handle. Most modern day network operating systems. It is based on the client-server architecture, meaning servers generally are not used for productivity. Meaning you're not going to browse the web, you're not going to type a paper, you're not going to play games on it. Most servers never even have Internet Explorer used on the server at all. Because if you don't know this, the more you use the internet on any device, the more susceptible are, even with antivirus, for viruses and malware and things like that. And so most servers don't ever even open up the web browser whatsoever. You might think, well, how do they install stuff? Generally, they install from a network drive or from a CD or from a USB drive, one of those three. It also has a managing resource component. What that means is if we were all in the same workplace and you guys, we all work together in the same department, we could all share the same database. Like say to enter in data for what we just went over on a call sheet for customers. We could all work on that together. If my computer died, no big deal. The database is fine. I just get a new computer, log into it, and access the database again. All right. It also has other functionality a network operating system does that's built into it. And it varies by the version of operating system you have and the type, whether it be a Linux, Mac, or a Windows environment. So here's some of the minimal requirements, which is what it means by that is definition is minimal, meaning you're not going to generally use it. And most minimal requirements for networking operating systems, a lot like your home computers, right? It says, on Windows 10, something like 2 gigs of RAM or something, maybe, or 4, I think it's 4 gigs of RAM. If you try to run 4 gigs of RAM on a Windows 10 computer, you're not going to be able to do much, right? It's going to screech pretty quickly. Same thing on servers. The minimal requirement for Windows 2012 was 8 gigs of RAM. Most companies run at least 26 or higher on memory, on gigs that they're pushing for that computer to that server to work. And so depends on what they're using it for, but generally when you buy any software, including network operating systems, on the box or on the label, it'll give you minimal requirements that's needed. And they have to do that, by the way, for the IEEE and for the network operating system companies and manufacturers that write the rules for these companies to build the software. That's be minimal requirements. It's the same thing with, I don't know, if you've ever built a house or you've ever built anything, there's always minimal requirements for everything that you buy or build. You ever notice that? Even a car gets off the assembly line. There's a minimal requirement for that car to meet off the assembly line. It might not have a sunroof. It might not have, the built-in Wi-Fi, but it has to have, this, and this. It has to have working brakes, steering, turn signals, brake, all the functionalities that a car has to have to drive, basically, for safety purposes. Same thing with servers. There's minimal requirements and optimal requirements. So questions you ask when you're thinking about optimal requirements for anything, especially servers, is what kind of applications will we run on the server? Say it's a Microsoft Exchange for email. That's pretty beefy. It's running all day long, 24/7, and it's highly a lot of processing power in that server. So it's going to need more memory, more hard drive space. Also, how many clients you're going to connect to it. That's important as well. The more clients you connect to a server, the more bandwidth you're using. How much storage space will each user need? That's important to note as well. Most companies have anywhere from 5 megs to unlimited, depending on the company, how much storage space you get, how much downtime is needed or is required or acceptable, and what can your company afford. All important questions to ask. So applications, believe it or not, there's a lot of applications that run off servers. Microsoft Office can run off servers. All your graphic design programs can run off servers. Adobe, InDesign, Quark Express. A lot of your graphics and media type softwares can run off servers as well. More applications you have running off servers, the more resources you're having to use on your network. And it's being drug across the lines on your network, meaning it's going to slow it down for everybody. Vendor reputation requirements, make sure you use folks that are highly qualified and dependable and have high support. And on server reliability, spending as much as necessary because you don't want component failure and widespread failure. Like say you buy cheap routers or cheap switches or cheap operating system or cheap programs for your server, it could cause problems down the road. Free is not always good. I like free, but free is not always good. Now, client support on network operating systems basically allows for efficient communication, allows for client support like creating and managing client accounts, like we're going to be doing in a few weeks, enabling clients to connect to the network, allowing clients to share resources, managing clients' access across the network, and facilitating communication. Logging in, there's generally a login script that maps all the drives on your network every morning when you log in. Somebody's got to create that, and then somebody in IT is going to do that. Over the years, I've had to create a lot of login scripts to do a lot of different things, from just not mapping net drives, but maybe running processes and procedures and reports and things of that nature. Redirector, this is basically where it intercepts problems or requests and determines how to handle them. That's generally a high-end switch or router. And then file access protocol, these are the different, every computer, every operating system runs on different file access. NTFS is a popular one, starting with Windows XP to modern day Windows 10. And it's a different file system for writing files and reading files. The other one, CIFS, which is Common Internet File System. SMB, which is Server Message Block. It's an older protocol. But basically, an example is this on file access. If you don't set up, like on your network clients, some of you had to go around tonight and configure your IP address to be auto-config. One of the IP address configurations in your NIC card is sharing files. If that's not checked, you can't share files with anybody. And if people can't share files with you. So it's a pretty critical component that's a part of that client server architecture. So on this diagram here, you've got the server and multiple clients constantly being redirected client requests back and forth. Like this one here is, the question on the redirector, and this would be a switch or probably more likely a router. Is this request for the server? Yes or no? It's constantly being asked all the time. An example is if you host your own web server in your local business or home, when it comes in through your router, it goes to a unique computer on your network to load that website, and your router is going to know where that is and redirect. And that has to be configured in there and ruled in there literally by hand on where that IP address is. But you can have an external IP address coming into your house or building for your work and going to a local IP address for a web server. And this would just pretending this one's a web server, but it could be a number of things. It could be an email client. It could be an authentication server as well. Middleware. That terminology is basically things in between you that you're sitting in front of, that computer, and the server in the Cisco room. Okay, is middleware. Everything in between. So everything on the end of your table, the switches on the end of your table is middleware. Routers would be considered middleware. Hubs would be considered middleware. Your Wi-Fi access point would be considered middleware. Anything else you can think of to be considered middleware, maybe? About it, right? Those devices right there. You can have others, but those are the most popular. Three-tier architecture is basically where you have a client-server architecture incorporating middleware, which you're going to have in any environment, like in this environment. Client, server in the Cisco room, and multiple switches on everybody's table, including in the middle of the room in the back, we have one of the switches that actually goes under the floor. The Cat 5 wire does, fiber does to the Cisco lab. So here's the breakdown visually of the client middleware server architecture. All different types of clients can be in there, all different types of middleware. Client authentication. When you log in tonight with the student account, you're authenticating to our network server as one user. We don't have multiple users. We'll have two users. We have administrator and student. It gives you access to the services of the network operating system. So you can share files, you can get your shared drive. The administrator account on a network operating system has the most privileges, and they have unlimited rights to everything from printers to users to domain controllers, and it's created by default. One of the things you want to do on your home machines, definitely, and even on clients at work, is turn off what's called the guest account, because it's sometimes turned on and left on, and that's easily hacked into and backdoored in by a lot of different programs. But the admin account generally is forced to set a password whenever you set it up on a network operating system. The modern servers will anyway force you to do that. Usernames. You have unique usernames on the network to be able to log into. Groups. There's an entity and network operating system called Active Directory, you might have heard of. Active Directory, we do offer here on campus a 6 to 8 week class on Active Directory I recommend taking. And basically it teaches you management of users and groups and printers on a server. Being able to add, not just add like we're going to do in a couple of weeks, but be able to create groups, create rights to those groups. Like for instance, half of us in here could be one department, half could be another. When we log in as a marketing department, we can't see what the sales department sees and vice versa. Might be some folders we can't see, some printers we can't see, and those are all done in Active Directory. So regardless, wherever you logged in on the network, those rights will be pulled down to you as a user using Active Directory and group management. So here's an example, using the school as an example. Users and groups. So groups, you got teachers, students, administrators. There's a rights to programs, rights to grades, and rights to staff. You'll notice on the rights to programs, teachers can read and modify, students can read, administrators don't have any access. Rights to grades, teachers full access, students no access, and administrators can read and modify. And then rights to staff, no access from teachers, students, but administrators have full control. And all this can be done in Active Directory and can be done on the network level. Nesting users and groups within an Active Directory. Basically, all you need to know about this is when you create a group, it's like a bucket. And in that bucket, you can have multiple permissions to printers, to file servers, to resources on the network. And if I add you as a user into that bucket, you now have all the permissions of that bucket. Okay, the parent bucket, you now have permissions of as a child in that parent bucket. Make sense? If you move from that bucket, from that department, let's say it's marketing into sales, you also now get stripped of the rights you had in marketing. Now you have all the rights of sales when I move you in that bucket. And so that's the beauty of Active Directory groups, is you don't have to individually give people rights. You literally give group rights, and then you add people to those groups, and now they have rights of the parent, which is that group, to do their functionality, whatever it might be. Administrator, sales, marketing, whatever the case may be. You can even do restrictions that way as well easily. Modern network operating systems allow you to easily add users, printers, servers, data files, and other applications. You can even do anything called fat servers and thin servers. Fat servers, basically where I can push to you guys as a group an operating system from my server operating system. If you've ever worked in retail, like Sears, JCPenney, when you walk around the building and look at people working in those buildings on their computers, they don't have any type of hard drive or CD-ROM or any USB drive. It's all just basically a monitor, a dummy black box with an Ethernet cable, keyboard, mouse, monitor plugs, and that's it. Everything is being pushed to them through a fat client from the server. And that fat client server might be located in California. I don't know. Doesn't have to be here locally. Thin client is where servers can basically push certain parts of your operating system that you need to you as a client and control everything you see and do. Meaning that you cannot do things without the server's permission to do something. And what's nice about either one of those is the fact that you no longer have to worry about people installing things or people downloading things, because you control it, everything from a network perspective. And you'll see that a lot in sales, and you'll see that a lot in retail. Retail departments will do that, and manufacturing as well. Ldap, this is basically an open source. We still use it today in all of our authentication for Mac and PC, for network operating system, Mac and PC and Linux. And it's basically used to store information about objects like a person, generally, and about that person's properties, which would be your location on the network. An example would be this here. If you're a part of the student group and we're RVC domain, the dot would separate the group, and this would be the user bucket. Actually, the user group, student. This would be called what's called a branch. And then this is a user. Also, this would be referred to as a leaf. Now, the reason I mention that is, and this would be also like a root is what it's called. In networking, a lot of times, when we're describing networks, it's always like a reverse tree, okay? You got your root first, your branches, and then your leaves. Can you add to a root on a tree? Can you add to a root once it's in the ground, starts going up? You can, right? You can add branches to a root. Got the trunk, right? Branches off and branches. Can you add to a branch? What can you add to a branch? A real tree branch.
Leaves.
A leaf, there you go. Can you add to a leaf? No, can't, right? Leaves it. Leaves is the last thing. So you can add to a branch student, which would be student group in this case. I can't add to a user cconcle, but I can add to a bucket, the group, and call it students, staff, faculty, whatever, and add a whole bunch of users into that, which are leaves. So just remember, we'll go over it more later. Root, branch, leaf when it comes to networks. So a reverse tree is basically the objects that help you understand how a network works and how you can add things. Ldap also has two different types of schemas. The schema is kind of roughly what I just drew up here. Schemas are broken apart by what part of the tree you are. It always starts with the root, which is a company name usually, like here's RVC. If you work for ABC company, it might be ABC. If you work for DEF company, it might be DEF, okay? And then you got from that all the branches, which could be your departments or divisions. So instead of student, it could be sales, marketing, HR, maintenance, yada, yada, yada. You get the point. You could even have a branch called printers, has all your printers in it. A branch called applications, that has all your applications in it. And then you can give rights and privileges to each one of those branches, those buckets, You can rights and privileges. That way, when you add anybody to it or any entity to it, it thereby gets all those privileges and rights of that. So here's an example. It's using, in this object class, user account, computer account, printer account, and domain. Domain would be RVC, would be domain here on campus. Printer, we got a printer right there. It's on the network. Computer, you're sitting in front of. User account, you logged in. Student. All entities are here in this room. Same with your workplace, same with your house, even when you log into Comcast or Xfinity, wherever you have. Same type of thing, just more global. The schema is made up basically, you can think of schema as properties of a user or an object. Ldap also has what's called OUs, or organizational units, that are subdivided logically, just like this here. And it says on this slide about the tree concept I already mentioned. The first network operating system, by the way, that I worked on years ago was Novell. Anybody heard of Novell before? Novell operating system? Novell was very popular in education and manufacturing. And it actually had, when you double click on the network tree, it was a tree. It looked like a green tree, literally. Okay. And then it would break apart into different branches and then different branches from that. Windows doesn't do that, but Novell did that. It was kind of cool. And it was a very efficient network operating system. The problem with Novell was Microsoft. It couldn't compete with Microsoft. Microsoft just blew them out of the water with marketing and blew them out of the water every other way you can think of. Like any business can be blown out of the water with other larger business. Tree, I've already went over that, so I won't go over root, branches, leaf. That makes sense, right? Just remember on that, you can add to a root, you can add to a branch, can't add to a leaf. Another representative, by the way, of a leaf would be like a switch. Can't add to that. Hub, you can't add to that. It's usually the last thing. And the printers, you can't add to that. So here's a tree reversed, as you can see. The roots at the top, multiple containers or buckets, I like to call them. And each container, I always tell students, if you can think of divisions or departments, it's an easy way to remember it. Because when you're creating a diagram for a network, which I've done many times for businesses, that's what you do. Your containers become your departments. How many departments you have, that's your containers. Because in those departments are going to be people, hopefully, right? Working, hopefully. Inside of those containers, you can have subcontainers, right? And then within those subcontainers, you can have finally leaves, which could be users, printers, file servers, things like that. So before installing a network operating system, you need to plan the tree. You did that a little bit the second week of class. Whenever I had you draw that diagram and come up here and put it on the board, you were just, throwing together, I think it was 12 computers and a couple servers and file servers and printers. You were doing that right there. You were diagramming stuff, right? It was very crude, but you were doing that. So that's what you have to do before you install a network operating system, buy anything, figure out what you're going to need now and in 5 years and plan for that. If you don't plan for 5 years, you're going to kind of short yourself when it comes financially, because most financial accounting departments and companies will go, well, why didn't you plan for this if it's a year down the road and you're needing more computers or you're needing more servers? You should have known that, and you should know that. And so you have to plan ahead by asking how many more people are we going to hire in 5 years? What's the projection? They're going to know that, by the way. You might not know that, but somebody's going to know that, right? Or they should, hopefully. Are we going to have another location? I don't know. Maybe so. Again, you ask people to know that if that's the case. So ask the pertinent questions to figure out what growth you're going to have, and then you can put 5-year plan into the budget. Most networks will roll over computers in a business every 2 to 3 years. The job I work at during the day, we have about 150 desktop laptops that are turned over every 2 years, from Surface Pros to iPad Pros to laptops. And so any business is going to have that type of cycle that we put in our budget to make sure we can afford it. that new cycle. Same thing with network operating system. There are companies like CDW. There are companies that's one I recommend that does very well in putting quotes together for you. But before you do that, you have to know kind of what you need first. What's your head count? What's going to be in 5 years? That's what you have to know for sure. At least that foundationally. This diagram here just gives more broken down real company type thing. So we got Circuits Now. When I think of this slide, I always think of Circuit City. Anybody remember Circuit City? I love Circuit City, man. Hate it when they shut that thing down. I hate going to Best Buy. Do you got anybody like that? But is it just me? I don't know. I like going in there to look at stuff, but I don't like going in there and buy stuff. I do go in there and look at a lot of stuff, and I have a lot of my students that work there, and they get they tell me too. Well, come in here and look at it, but don't buy it. Go buy it online. And so, but Circuit City was an awesome place. You could just go in there, nobody bother you, and you just walk around there for hours, and nobody ask you a question. It was great. But Circuits Now is this one. Printers, users, computers, really crude layout there, but they're looking at the future here. You see. We got in the future, we have a chips department coming up. We got a transistor department coming up. So that means more switches, more servers possibly. We put that in our budget, so we'll have the money come budget time. Sharing applications, I already talked about that, but I didn't talk about this, which is a licensing type. I did talk, I believe, about Quark Express, Adobe, those products. Those are good examples. When you buy licensing for software, specifically network operating system, you can buy per seat, which would be per user, or actually per user or per seat. Per seat's called concurrent users, meaning if we have 150 cap people in our building, like that's max, but we generally have maybe only 50 people in our building on any day, we can do a concurrent license of say 60 people. Right? We don't need to buy 150 licenses. We're never going to use them. Per seat is you literally buy a seat license per user. Now, per seat would be like for small companies that have 6 people, 8 people. Perfect. Companies that have the fluctuation like I talked about are going to do the concurrent one, which is the seat license or the concurrent license. And then site license is for companies that have so many people. It's better for the money spent to buy a site license. Site license is more expensive, but there comes a time to where concurrent and user will surpass the price of site license, and that's where you have to kind of determine where you're at. And it depends upon the time of year you buy it, but even Microsoft has these type of licenses for the network operating system. Per user, concurrent, which is seat, or site license. And site license is unlimited, basically, but it does cost more. Sharing applications on your server, you can definitely do that. Many companies do. And they have what's called license checks. What a license check does is, if we have the concurrent license of, say, I don't know, 50 people, and 51 comes in to log in, not going to let them log in. It'll catch it. It'll verify that they have that license and tell them, you need to wait until something opens up. Problems with sharing files. Basically, if everybody's trying to access the same file, that can be a problem. It can be. If you ever try to open up, like, say, a Word or Excel document that somebody else has had opened up, and you try to go in there and edit it, what's it tell you when you try to do that? Yeah, Joe's locked. He's got Word open, and I can't do it because it's locked. So I'd wait for Joe to. Now, what's cool about Microsoft is they do say, "Would you like to be reminded when Joe gets out?" And you can say yes. And so when Joe gets out, I'll get a little pop-up on my computer saying Joe's out, and then I can go back in. It's smart enough to do that. But there's problems with files beyond Microsoft. Like, say, for instance, it's a a text file or something that literally only one person at a time can open, or some type of weird database file. You can have problems with that on shared resources because if everybody can access it, everybody can access it, and that can be a problem sometimes. And so again, like I tell people all the time, even though we have the technology to do things much faster, that doesn't mean you don't need a process, right? Just because we can, I don't know, do something without rules doesn't mean we should do something without rules. Does that make sense? And so same thing goes with this. Like an example is, I don't know how many times, this is kind of funny, we had to actually get onto people for talking on their speakerphone to guys 2 cubicles down. Huh? They're 2 cubicles down and they're talking on speakerphone. And so everybody around them can't hear because not only they're on speakerphone, but they're loud. They don't even really need speakerphone. Anybody know anybody like that, by the way? And so, you know, the process, you know, with networking still needs to be work with people, like on this example here on a file access issue, when you can access the file, what time of the day should sales access it or marketing or whatever the case may be. Networking is not going to always solve the problem all the time. Sharing printers, same deal. I have seen printers get overran in the queue and backed up because everybody is trying to, and their brother is trying to print to it versus working some type of process out or procedure out to effectively use that printer. But printers are connected to a network, and I'm sure most of you, some of you have maybe, how many has printers set up on your network at home or on a computer at home where you can actually print to it or something? Yeah, we all can do that, right? Well, on a network operating system, you actually have the ability to attach a printer to a network domain. And once you do that, you can then just go to the domain like rcs/printers and see a whole list of printers on your network that you can just literally double click on and connect to and print, which is nice, right? And modern operating systems, I'm saying for the last 8-10 years have been able to do that, but not that long. 10 years is, you know, we're still infancy stages when it comes to networks still, as far as the speed of things. Here's an example of sharing printers. You've all seen this. You know, you got your printers networking, maybe in another department, in your department or whatever, and you can print to it, and not have to worry about it and go up, you know, have somebody go get your print job, or you go get it for yourself or somebody else. Sharing printers, I won't bore you with that. You should know how to do that. If you don't, it's real easy to do, even on networks. Made it very, very simple to do. When it comes to managing system resources, though, this is important to note that the network operating system maximizes server memory, processor, bus, and hard drive use. And what that means basically is it really stresses them out. It pushes them to the limit. Here on campus, if we have an issue with a server, what do you think 99.9% of the time we have to do to that server? Just guess out loud. If it's locked up, if it's, you know, slow, there you go, restart. It's the same thing you guys do at home. It's the same thing you do at work. If your computer is slowing down, you restart it, right? It's running out of system memory, it's running out of processing power, whatever. To this day, even with modern day network operating system, with all the boatload of memory we have, the boatload of hard drive space we have, there's still times on a monthly basis we have to restart servers. Just like you have to restart your computers at home or your computers at work. The only unit I can tell you that's not like that, network operating system that's not like that, is Linux, in my estimation, in my experience. Linux is made and designed much more efficiently than any other network operating system or operating system for that matter. Mac's pretty good, but Linux is even better as far as capability of managing memory. And one of the reasons for that is the core of the Linux operating system was called a kernel. And anytime, if you were to work on a network operating system that's built on Linux, anytime a user connects to that Linux kernel, it creates an entity, another entity of that kernel just for you. And so if you get all messed up over here, it doesn't affect anybody else around you. And so that's how they created the network operating system, Linus Torvalds did. And Linus Torvalds created the network operating system for Linux back when he was in college as one of his final projects. because all the network servers, all the servers and the computers on the school was too slow. And so he said, I'm making my own. So that's what he did. And he retired, by the way, at 44 years old, believe it or not. He's only like 54 right now, 55 years old. It's like crazy. But anyway, a Linux operating system, you can, and the web servers are using Linux operating system. The number one web server operating system is Linux. 78%, the last I heard, worldwide running on Linux. You can literally install the server, install your web server, unplug the keyboard, mouse, and monitor, just shove it in a corner and forget about it. Because I always share this story with my students every year when I share this about Linux. My father-in-law, how many has challenged people at home when it comes to computers or in your family? They're a little computer challenge maybe, and they know you know a little bit about computers, right? And you are the person to help, right? You know that? Well, my father-in-law was one of those folks, and so he had Windows, what was it, not that XP, what was it? Yeah, Windows XP. And every time I go, I have to do, clean up malware, viruses, clean up whatever. And he really didn't do much, but email. He would connect his camera to his computer to print it out. That's about it. That's about all he did. So I brought a Linux operating system. It's called PC Linux, is what it's called. Really good version. And it's really good for people that are PC people. That's why it's called PC Linux. Anyway, I installed it on his computer. I wiped out his hard drive, installed it on his computer, showed him how to use it. 5 years later, not one instance with that computer. 5 years. He finally just, it just got old basically and just pooped out. But he got another computer with the same operating system on it and loved it. And so if you have family members that have computer problems all the time, you might think about, and if all they do is web stuff and email and print, print pictures and social media or something like that. And by the way, you don't even have to put antivirus on it. Never had to put antivirus on it. Didn't have to. They're not targets for viruses. Linux isn't. So if you have folks at your house or your family, that's what I recommend. And the version I recommend now to install is Ubuntu. Ubuntu is the one I recommend. Really easy to use, and you don't have to worry about it. Once you install it, you can actually figure out how to use it pretty quick. I definitely recommend you doing that before you install it. But it's super, super easy to use, and you don't have to worry about it. So hopefully that'll help you with some headaches like it did me. Memory. Servers can use boatloads of memory, as I already mentioned. They can use virtual memory, hard drive memory, physical memory, tons of it. And what I mean by tons of it is you have to remember the network operating system can hold up to 32 processors, some of them even more. And each processor then has a max amount of memory it can handle and a max amount and basically just daisy chains that memory. So we can get memory up pretty high on these servers. Advantages of virtual memory. Really, today's network operating system, even Windows 10, you really can't mess with virtual memory anymore. You used to be able to, but it pretty much manages. Windows pretty much manages it for you now. But it does have virtual memory, but it does it for you. And basically what it does is it engages your hard drive when it needs to for that memory that it needs. So if it's running low on physical memory, it'll use part of your hard drive. Your computer at home will do this, by the way. Your laptop, desktop will do, your phone, your tablet, whatever. They all do this now. And so the advantages is on virtual memory is it will do it for you, the software will, and manage that for you for when you need it, those peaks when you need it. Multitasking, another thing built big on servers. It can do a lot of tasks at one time. It can log people in, handle every message from an email. The average company, 97% of their emails coming in is spam, 97%. That's millions and millions and millions and millions of email a week coming into an average company, medium-sized company, that's junk. And email servers have to handle that. Email filters have to handle that, like Barracuda, to filter all that junk out. And even your personal email. If you go check your Gmail junk folder once in a while or your Yahoo, whatever it is you use, You'd be amazed how much junk is in there that it just throws in there on a daily basis. Multitasking is definitely used a lot in servers and help because of the processing power and the threading. Basically, all you need to know about threading is the fact that it can hold millions and millions of threads more so than a regular computer can at any moment notice. Because again, you're talking, yours and my computer has at most a quad processor, right? You're talking servers having 64 of those. Okay, it's going to be able to handle a little bit more than your regular computer, right? And it should, because it has tons of processing and users connected to it. Multiprocessing basically allows you to do multiple things and expediting things much quicker, which servers allow you to do. On this slide on multiprocessing is know that servers can handle multiple tasks at any time simultaneously, from logging in to redirecting login scripts to blocking things to giving people access to things. Here's the minimal requirements I talked about earlier. This is for 2012. Let's see, 1.4 gigahertz processor, which is a very small processor, 64-bit, 512 mega RAM for a server. You guys have that on your, I don't know, the card on your phone on your phone at home. You know, the 512 mega SD card. Probably have bigger than that, right? 32 gig SD card. I don't know. But 512. This is just 2012. This is a few years back, not that long ago. And by the way, 2018, they've just bumped it up. 2018 only requires 2 gigs of RAM. That's it for minimal. So you're never going to do that. It won't work. But again, they put this on the data center and on the, I have to do that. 32 gigs of available disk space, network card, yeah, and a graphics card. But again, all basic stuff, right? I mean, just like the base car. One of the first cars I had was a Maverick, and they were really ugly. A Ford Maverick is a very ugly vehicle. But I liked it. It was about 16. When you're 16, you like pretty much anything you get, right? And so, you know, I got it beefed up. I got some new tires on it. Got a new Hemi in it. I got, you know, new upholstery in it. I did body work, so I could do that. I got that. I still did that myself. So I was pretty happy with it, you know. But when I got it, it was a base. It was just, you know, at an AM radio. That's it, not FM, because that's upgrade. You know, and so, you know, very basic. But same thing with your data centers and your new network operating system. They have basic requirements, but that's generally not going to be what people do. People use it for anyway. Okay. When you're installing servers, all you need to know about this is that you basically have to go through the process of installing it. Most server OSs today anyway, you're going to install it from a DVD. And most servers, by the way, or most of they call them blade servers, don't even have a DVD on them. You literally have to plug in an external DVD to install the network operating system. Server cores basically are just different types of servers that have a different, what's called a smaller attack surface or smaller form factor than others. And they're made for like cloud computing. I'm trying to think. Nexus was one that's out right now. Because, you know, everybody's doing cloud computing. So the way new cloud computing work with networking folks is I'm not going to get a cloud out there and not have something here. And so there's hardware appliances you can buy now that mirrors what's on the cloud on your location. That way, if the cloud dies, which it can, right? It can fail. You've got something locally backed up. Administrators can switch now between different versions of server with virtual server operating systems. And it goes on the minimal server interface, talks about the deployment using what's called Powershell, which Powershell is really huge now. By the way, Powershell is actually being surpassed now by Python. And if you're familiar with anything coding-wise, Python's a popular language, and it's overriding PowerShell now. And all you know about, and we do teach, by the way, some PowerShell here on campus a little bit in our Cisco classes. Not much, but we're going to teach more. And PowerShell basically just allows you to do certain configurations for servers via scripts and stuff like that without having to go into a GUI interface. Lastly, we'll talk about domains. And basically, a domain is what I wrote up here, like the RVC domain. Has in it a group of users, servers, and resources available. Has an active client-server architecture. And the Active Directory, which I mentioned earlier, which helps you manage your users, your printers, your organization, and give rights to everybody on the network. And so lastly, we'll look at this page here, which is on page 39, which is a university domain, kind of like ours. And you'll notice it's broken down by the different departments, which in this case you have life science, humanities, communications, engineering, chemical engineering, industrial engineering, electrical, and mechanical engineering. Multiple domains all in one organization. Or you would say, in networking terms, one root. Okay? Remember the reverse tree. The root here would be the university domain, would be Rock Valley College or MIT or Rockford U or whatever. And then all the sub domains are those departments. Okay? All right, so let's do this. Switch gears. If you go into the lab for this week, well, I'll take it back. I'll just give it to you this way. You don't need to go into the lab. Well, do go into the lab to submit your name. Do that, yes. Definitely do that. At least I know you're here. You're not going to turn this in tonight, but we're going to get started with it. I'm going to take home. We'll just do the first line on each one of these sheets. And you will need a pencil or pen if you don't have one. I have some up here. You can borrow one up here if you want to. Have a little cup up here with some pens if you want to. It's up to you. Or not. You can just follow along. Is that what you want to do? Okay. Yep. That'll work. Okay. So I'll pull it up here on the overhead. Okay, and I'll have you guys help me on this. So this first sheet, is you're going to use the first number of the IP address to identify the default class, associate the subnet for that address. Number 2, calculate the network ID using the numeric values in the IP address that correspond with the 255s in the subnet, and fill the remaining with zeros. Number 3, calculate the host ID by using the numeric values in the IP address that correspond to the subnet. Now, before we do this, go to page 2, and you'll know why after we do it. Page 2 goes over the classes. Here's the classes. If an octet of an IP address, the first octet of an IP address starts with a 1 to 126, it's a class A. If it starts with 128 to 191, it's a class B. 192 to 223, it's a class C. You'll notice the network and host ID portion. On the network ID portion, starting with class A, it only uses the first octet, which in this case is calling it W. Because remember, every IP address has 4 octets, like a 192.168.1.1. That's 4 octets, okay? So the first octet, network ID portion for class A is W. The host ID portion of that class A would be X, Y, and Z, the last 3 octets. Available networks is 126. Host, that 16 million number. The next class B, you'll notice it uses, for the network ID portion, W and X, host ID, Y and Z, that many available networks and that many hosts. Class C uses the first 3 octets for network ID portion. Host is the last octet. The 2 million for available and 254 for host. Now, some of the guidelines, it's good to read. I want to assign a network ID. And for tonight's purpose, by the way, for the network ID is going to be always going to start with 255. So where you see W, X, Y, and Z, W, X, Y, and Z will always represent the numbers 255. Each one of them will represent 255. So class A will always have 255.0.0.0 as a default network ID. Class B will always have 255.255.0.0. Class C will always have 255.255.255.0 as its network ID. You can change that, but that's the default. Okay, so network ID must be unique to the IP network. If you plan on having a direct connected to the public internet, the network ID must be unique to the internet. If you do not plan on connecting to the public internet, the local network ID must be unique to the private internet network. What I mean by that is, remember when we did the lab where you guys connected one to the other, and you were like a 10.0.0.1.2.3? Remember? You weren't connected to the internet then. You were just connected to one another, right? In that local Class A environment. Next bullet point, the network ID cannot begin with 127 because 127 is reserved for the local loopback, the 127.0.0.1 or the home. Number 3, all bits within the network ID cannot be set to 1. All ones in the network ID are reserved for what's called a IP broadcast address. 4th bullet, all bits within the network ID cannot be set to zeros. All zeros in the network ID are used to denote a specific host on the local network and will be routed. The following IP addresses are non-routable in the document RFC 1918. And so these are some private IP addresses and can be used on private networks like in the building here. A 10 dot number through that is Class A. 172 number through the 172 numbers, Class B, and 192 through the 92 numbers, Class C. Most of you at home are in that Class C environment when it comes to your Wi-Fi, I'm guessing. Probably start with the 192 number. That's going to be default for Linksys as out of the box. And that's good enough to basically have a local internet in your home, intranet, and then local internet externally connected outside to be connected to the internet from Comcast or Xfinity. I say Comcast, we used to be that for you. I know it's called Xfinity now. But you guys know what I'm talking about? All right, so let's go to page 1 and we'll do this together. So the first one's done for us. So the IP address is 129.102.197.23. The class for that is a B class. So the subnet, because it's a B, it's going to use the W and X, the first 2 octets. It's going to be 255.255.0.0. And by the way, you use that to determine the W, X, Y, and Z to determine the network ID and host. So the network ID is going to use the first 2 octets. The host ID is going to use the last 2 octets. On the network ID, if you don't fulfill the 4 octets, you just put zeros there like it shows you here. So let's look at the second one. What class is the second one? B. All right. And subnet? Yep. And network ID? Mm-hmm. And host ID? 2.1. All right, got it. So that's how you do that. Now, there is one of these on here. That's a tricky one, but we went over it on page 2. Just note, you probably would have seen it before we started. Fill all those out, every one of them. Bring it back in 2 weeks. Go to page 3. Here we're going to show you how to convert binary to decimal to binary. So in here we're going to convert the first decimal to binary, second decimal to binary, third, fourth to binary. Then we'll add leading zeros to the binary to complete an octet. And an octet, by the way, has to have 8 bits. So I have to have 8 slots per octet. And that's referring to the right column, by the way, when we do that on number 5. And then we'll also separate the 4 binary octets with decimal points. So to do this, what we're going to do is use the calculator on your computer. All right, so I'll do it with you. It used to be called the scientific calculator. It's now called the programming calculator. So if you get on the Windows machine on your computer, go to the Start button, Accessories, and we're going to go to the calculator. As soon as it comes up, we're going to go to the View menu and select Programmer. Then you should see a calculator that has 0 in it. And the only buttons available to you right now, well, it should be all of it, it's on decimal. What I want you to do is on that first one, which is what, 215, we'll do that one together. I type in 215 and then click the bin radio button. It gives me the binary, which in this case is 11010111. That's what you're going to put on the first in the binary portion column is that 11010111. Okay, somebody else do the 34 for me. What do you got on 34? And before you do 34, make sure you click on the decimal again. Before you do 34, then bin. What do you got?
00010.
Okay. How many zeros are we missing? You don't have to fill it on this column, but just kind of know in your head how many are we missing on this.
2.
2? Yep. So go ahead, put that in the comma. Put a comma in that number there, which is 100010. Third number, somebody else do that. 211.
11010011.
Okay. And then somebody else do the last number, which is 9. Great. Now, when we break these open, all you need to do on the other side on the binary IP, you'll notice on the binary IP, all you need to do is put zeros in front of the binary number you just put in there that does not have 8 to fulfill 8, basically. You're going to put zeros in front of to fulfill 8 and replace the commas with periods, basically, is all you're going to do. So make sure each one has 8. Like that last one only had 4, so it would have to be 00000, and then 1001, I believe, on the last one. Okay? You want to do that? So the binary, you're just doing a straight conversion. Don't worry about adding the zeros, separate by commas. The binary IP address, you're separating by decimals, and you are completing each octet with the leading zeros to complete that 8-bit octet. Because every bit, the reason it has to be 8, by the way, is a byte is 8 bits. Okay? 1 byte is 8 bits. It's either a 0 or 1, or a true or a false, or an on or an off. That's all it is. And by the way, we didn't watch it in class, but there is a video I put in there of a guy that does a really good job, better than me, on doing a really cool way. It's a 9-minute video on how to do a binary to IP and binary and an IP to binary all by hand. It's a 9-minute video, and you'll learn it really easily doing it that way. It'll be in your head once you watch the video. It's pretty easy how to do it. Everybody got that? Cool. Let's go to the next page, which is the last one. You're going to do reverse now. Use the scientific or the programming calculator. You're going to this time enter in the bin radio button, enter in the binary, and then hit des to find out the decimal. So I'll do the first one, which is that one page open here. I'll do the first one for you. So the first one is 0111 0110, and the this is the wrong way, sorry. Clear. 1010 001. Now we got it. No. All right, 118. 118, there's on to Tron. 118 is the, oh, I did the first one that's already done for us. I did the first one. Let's do the second one. Sorry. 10 10 1001 is 169. Okay, do that on all 4, separated by commas, and then on decimal IP version, you will just replace the comma with a period. That's all you gotta do. Okay, you'll fill these out, completed. Bring it in not next week because we're not gonna be here, but the week after, turn them in. Questions about that? All right. We'll see you in 2 weeks. Make sure and get a lot done in your outline. At least you're out. Watch that video I have next week. That Prezi will help you. And at least get your outline completed next week would be awesome. That will help you with your research paper and presentation, which will be here before we know it. All right. Have a good week.